Welcome to another tutor short provided by the Educational Support Services Department at Lehigh Carbon Community College in Schnecksville, PA, just outside Allentown. These videos cover key concepts for math and other math-based courses here at L-Tri-C. Please remember that the Educational Support Services Department does provide walk-in tutoring 5 days a week in math and other subjects. This tutor short video will cover graphing linear equations and linear inequalities. There are several methods you can use to graph a linear equation. The first is using a t-chart, which may require you to find some points. The second is using slope-intercept form, which may require you to manipulate the formula into slope-intercept form. And the last method we're going to use is finding the x and y intercepts. First, we're going to start by using a t-chart. We have the equation y equals x plus 5, and then we have a t-chart with 3 points listed in it. The first is negative 2, 3, so on my x-axis I go to negative 2, go up 3 on my y-axis, and I get my point. Next is the point 1, 6, go to positive 1 on my x-axis, up to 6. There's another point. And my last one is 5, 10. Over 5, up 10. I have 3 points. I can connect them with a line. And there is the graph of y equals x plus 5. Now this one was fairly simple because we were given the points in the t-chart. That's not always the case. Here we have y equals negative 1/3 x plus 1. I need to fill in my t-chart. So I need to start by picking which x values I'm going to use. A nice simple value to use would be 0. So it's negative 1/3 times 0 plus 1. Negative 1/3 times 0 is 0, plus 1 is 1. So my point is 0, 1. I want to find 2 more points, so I need to pick 2 more x's to use. Since in this case I'm multiplying x by negative 1/3, I'm going to pick 3 and 6, since those are both multiples of 3. Negative 1/3 times 3 plus 1. Negative 1/3 times 3, this 3 is over 1. 3's are going to cancel. So I'm going to have negative 1 over 1, which is just negative 1, plus 1, which is 0. This point is at 3, 0. My last number that I'm going to use for x is 6. So I get negative 1/3 times 6 plus 1. My 6 is really over 1. I can reduce 3 and 6 to 1 and 2. This is going to be negative 2 plus 1 is negative 1. My point is 6, negative 1. So now I need to plot my points. The first was 0, 1. So 0 on my x-axis, up 1 on my y-axis. My second point was 3, 0. 3 on the x, 0 on the y. And then my last is 6, negative 1. 6 on my x-axis, negative 1 on my y. I have my points. Connect them with a line. I always like to find 3 points when graphing by this method, because 3 points will make a line if I've done them all right. If I only have 2 points, I'm not going to know if I messed something up. So now we're going to graph using slope-intercept form, which we know is y equals mx plus b. M is your slope, b is your y-intercept. So my first equation, y equals negative 2/3 x plus 4. My m is negative 2/3. My b is 4. So my b is 4, which means my y-intercept is 4. On my y-axis, I go to 4 and put a dot. Now my slope is negative 2/3. That's rise over run. So it means I'm going to rise negative 2. If I'm rising negative 2, that means I go down 2 and run 3. I'm going to run 3 to the right. Down 2, run 3. Now I'm going to do it again. Down 2, run 3. I have 3 points. I'm going to connect my dots. There's the graph of my equation. Our second example here is y equals 5x minus 1. My slope is 5. My b is negative 1. Since b is negative 1, my y-intercept is negative 1. I go to negative 1 on my y-axis. Now my slope is 5. That's really the same as saying 5 over 1. So I'm going to rise 5, run 1. Do the same thing again. Rise 5, run 1. Then I'm going to take my points and play connect the dots. Now in both of these examples, we were already in slope-intercept form. That's not always going to be the case. First I have 5y equals 3x plus 10. I need to get y by itself to get this in slope-intercept form. With my y, I have a 5 that I'm multiplying, so I'm going to divide both sides by 5. And I get y equals, because the 5's cancel, 3x divided by 5 is 3/5 x, plus 10 divided by 5 is 2. So now my slope, or m, is 3/5. My b is positive 2. So in the y-axis, I go to 2. My slope says rise 3, run 5. Rise 3, run 5, connect my points. My second equation here requires a little more work. I still need to get y by itself to get it into slope-intercept form. Start by subtracting 2x from both sides. I get 4y equals negative 2x plus 6. Divide both sides by 4. 4's cancel here. I get y equals negative 2x divided by 4 is negative 1 over 2 x plus 6 over 4 is 3 over 2. So my m is negative 1/2. My b is 3/2. So now I need to graph this. In this case, my b is not a nice, easy point. It's 3/2, which is the same as 1.5. So I have to estimate about where that is. Since it's a half, I can estimate that fairly well. My slope says fall 1, run 2. So I'm going to fall down 1 and run 2. Fall 1, run 2. And there's my points and my graph. So now we're going to graph by using the x and y intercepts. 2x plus 3y equals 6. To find my x-intercept, I let y be 0. So 2x plus 3 times 0 equals 6. 3 times 0 is 0, so that term goes away. So I have 2x equals 6. Divide by 2. x equals 3. So my x-intercept is 3, 0. I'm going to plot that point on my x-axis at 3, 0. So now I need to find my y-intercept. To find the y-intercept, let x be 0. So 2 times 0 plus 3y equals 6. 2 times 0 is 0. That term just goes away. So I have 3y equals 6. Divide by 3. I get y equals 2. This is the point 0, 2. And I plot that on my y-axis. I have my 2 points. I draw my line, and there's my graph. Now we have y equals 2/5 x plus 4. This one's even a little easier. We're in slope-intercept form. So if I want to find my x-intercept, I let y be 0. For my y-intercept, since this is in slope-intercept form, my b is 4, so my y-intercept is 0, 4. You could find this by letting x equal 0 and solving, but you don't have to, it's already right there. So that was 0, 4. Now I need to find my x-intercept. So I let y be 0. 0 equals 2/5 x plus 4. Subtract 4 from both sides. Negative 4 equals 2/5 x. To undo multiplying x by 2/5, I multiply by 5/2 on both sides. 2's cancel, 5's cancel. I'm left with x on this side. Put this over 1. 5 times negative 4 is negative 20. Over 2 times 1 is 2. Negative 20 divided by 2 is negative 10 equals x. So my x-intercept is at negative 10, 0. Plot that on my graph. I have my 2 points. Connect them with my line. And there's my graph. So now we get into special cases. Horizontal and vertical lines. Horizontal lines go this way. And every point on this line will have the same y coordinate. The equation is written as y equals a number. There are no x's in a horizontal line. The other type is a vertical line, which looks like this. A vertical line will have all the same x coordinates for every point, and the equation is written as x equals a number. There is no y in the equation. Some examples. Y equals 2. To graph this, I can come up with some points to use. Since it's y equals 2, I know my y is always 2. So I could call these points, say, 1, 2, and 5, 2. And we graph them on our graph. Here's the point 1, 2, and the point 5, 2. So here's my horizontal line, y equals 2. Next we have x equals negative 3. That means my x-coordinate is always negative 3. You can use negative 3, 0, and negative 3, negative 4. So negative 3, 0 is here. Negative 3, negative 4 is here. There's my vertical line. You don't have to make up points to graph these equations. If I look at y equals -1, I go to -1 on my y-axis, and then just draw my horizontal line through the y-axis. Same goes for x equals 4. I go to 4 on my x-axis, and then draw my vertical line through that point. So the last thing we need to cover is graphing inequalities. This is the same as graphing equations, but we have two differences. Sometimes we'll use a solid line, sometimes we use a dashed line. These inequalities do not have an equal sign, instead they have an inequality symbol. If it's less than or equal to, or greater than or equal to, we use a solid line. If we have less than or greater than, we use a dashed line. I remember this because solid lines have the extra line underneath. The dashed lines don't have that extra bit. The second thing we need to do differently is we need to test a point for shading. I like to test the point 0, 0 whenever I can. Otherwise, you can pick any point that's not on your line. We'll see some examples of this. First we have x plus y is greater than 0. This one I'm going to graph via a t-chart. For my x values, I can pick anything I want. I like 0, 1, and 2. So 0 plus y equals 0. What is y? Y would have to be 0. For my second point, 1 plus y equals 0. Y would be -1. And lastly, 2 plus y equals 0. Y is -2. So I plot my points. 0, 0, 1, -1, and 2, -2. Now I look at the inequality symbol in my equation. That is greater than. It does not have the extra line underneath of it, so this is going to be a dashed line. There's my dashed line. Now I need to figure out if I'm shading above or below this line. Now I said I like to test the point 0, 0 whenever I can. In this case, I can't because 0, 0 is on my line. So I can pick another point that I like. I'm going to test the point 2, 2. 2 for my x plus 2 for my y is greater than 0. 2 plus 2 is 4. Is greater than 0. Is that true? Yes, it is. Since that's true, I'm going to shade the side of the line that contains that point, which was right here, so I shade on this side of my graph. If it were false, I'd shade on the side without that point. So now we have y is less than 1/2 x minus 2. This time I'm going to use slope-intercept form. So if I look at this, my m is 1/2, my b is -2. So my y-axis, I go to -2. My slope says rise 1, run 2. Rise 1, run 2. Again, if I look at my inequality, it's less than. There's no extra line underneath. This is again going to be a dashed line. So I'm going to draw my dashed line. Pick a point to test. This time I can test my point 0, 0. 0 is less than 1/2 times 0 minus 2. 0 is less than 0 minus 2. 0 is less than -2. This is false. 0 is not less than -2. This point doesn't work. I shade the other side of the line. Now we have x plus 2y is greater than or equal to 4. This time I'm going to use my x and y intercepts. X-intercept, let y equal 0. X plus 2 times 0 equals 4. X equals 4. This is the point 4, 0. Y-intercept, let x be 0. 0 plus 2y equals 4. 2y equals 4. Y equals 2. This is the point 0, 2. I plot my 2 points. 4, 0, 0, 2. This time, if I look at my equation, initially my inequality had the symbol greater than or equal to, so this time I am going to use a dash or a solid line instead of a dashed line. So I'm going to go like this through my points. Pick a point not on the line to test. Again, I like 0, 0 whenever I can. I'm going to check this. I need a little more room to work. Zero plus 2 times 0 is greater than or equal to 4. 0 plus 0 is greater than or equal to 4. 0 is greater than or equal to 4. This is false. I don't want to shade that side of the line. I shade the other side. And our last examples are with our special cases of horizontal and vertical lines. Our first is y is less than or equal to 1. So just like if this was y equals 1, I go to 1 on my y-axis, and then I need to draw my line. Since this was less than or equal to, it's going to be a solid line. Now I need to figure out which way to shade. I can still test my point 0, 0. Is 0 less than or equal to 1? This is true. So I'm going to shade the underside of my line. Because y is less than or equal to 1, I want everything 1 and below. Last example, x is greater than negative 3. So just like if this was x equals negative 3, I go to negative 3 on my x-axis. Since this is greater than, I need a dashed line this time. Still going to test my point 0, 0. Is 0 greater than negative 3? This is true. I'm going to shade towards that point. And there's my graph of x is greater than negative 3.